Yes, hello, this is Teresa Benitez, and I don't know what I am in your class. I help with grading and stuff like that. So I'm going to start today, problem number 1 of your homework. Ooh, yeah. So this is going to last 15 minutes or less. Oh, such that it's not a pain. So this is optional, okay? And I'm going to be using your textbook. Ooh, it's right here. And then your homework, I'm going to be sharing my screen and stuff like that. So let me begin so we don't waste time. Ooh, share my screen, share the screen. Where is it? Share the screen, desktop, here we go. Okay, so this is your homework over here for Thermal 2. And problem number 1 says, using this equation that you discussed in class, estimate the molar volume in cubic centimeters per mole of superheated water, superheated steam at 10 megapascals and 400 degrees Celsius. And then you want to compare your result to those given in Appendix A3 for these conditions. And that's when we're going to use the book, right? So if you remember, where are my notes? Right here. Hold on, I'm going to stop sharing. From your class, and let me open that. Okay, here we go. Where's it? Well, I'm not sharing my screen, so let me share my screen quickly over here. From your notes in class, you have this equation for generalized Feng-Robinson, and you have that the pressure is the gas constant multiplied by the temperature. The temperature has to be in Kelvin divided by this minus this over here. So you have this equation, okay? And hopefully that was discussed in class, so we're not going to talk about that here, how to do the derivation, what each term means. And yeah, I talk pretty fast, so don't play this in double speed because then you're anyway. So you have this A and B over here, and they are defined in terms of the gas constant and the critical values. Okay, the critical values of the substance that you're using, and then you have alpha. You also have that equation in terms of the temperature that given for the problem and the critical value, and then you have K, which I'm pretty sure doesn't have 2 C's. But I don't want to correct my dad because he's awesome. So it's eccentric factor. And you can find these values, TC, PC, and the eccentric factor on page 254. We're going to do it together. You go to page 254. You're like, this is not MATLAB. What is this? No, not MATLAB, Mathcad. This is not Mathcad. This is some other thing going on. You go to your page 254, and you're going to find right over here, you're going to find TC, PC, and the eccentric factor for a bunch of substances from hydrogen to neon to oxygen to water down here, okay? So we're going to find those values for our program or our code because it looks like we're going to need it if we're going to use this equation. So from that table, you'll see this for your homework, TC is 647.3 Kelvin, PC is 22.048 megapascals, and the eccentric factor is 0.344. You can find that on your page 254. Okay, so we have this over here. And I did not have, oh yeah, you don't need this equation, okay, because you can find the eccentric factor from your table. So then from that, I'm trying to solve for V, okay? So there are some programs available on your Mathcad or UF apps, okay? So I'm going to go over here, and this is mass transfer, this is that. Okay, so this one is already available. And there's another one that has, I have another one here that solves for Z, which is the compressibility factor. So you can use that one too. You actually need to use that one for your problem number 2. But you have this one. And what I'm going to do here is just going to copy paste. And copy pasting sometimes is hard for me. So I did it before, you know. But this one, you can see that you already have it set up. And Mathcad is awesome because I'm going to show you soon. Well, apparently it's awesome. That's what my dad says. But here I can change the values. I can even change the units and it deals with the units for me. Like amazing. So here I have all the values set, and I'm going to change some of them, right? I have the equation for K, the equation for alpha, the equation for A, the equation for B already set up. Oh, this I'm just going to do copy paste. But then this one, this example, you had 2 phases here. We have saturated vapor and saturated liquid. So that's going to be a little different because for us, we're going to have superheated vapor, which is just one phase, all right? So I did copy paste. And I come here and I want to start changing my values. I'm just going to use that program because it's already available. All right. So you can use it. You can use the one and then you can do the PDF, submit the homework. So here T for my program, and this is it's been 5 minutes. For mine, it's where is it? 400 degrees Celsius, but I want this in Kelvin, okay? Why do I want it in Kelvin? It's an absolute temperature, okay? For pressure, I have 10 megapascals. Like, no, if I was using MATLAB, I have to start doing conversions, but look at that, just right here. Megapascals, it does it for me. Isn't that amazing? Isn't that, for me, that's amazing because I spent too long using MATLAB. MATLAB is good too. I'm not gonna hate on it. And then TC from my table. Looks like I'm starting the homework here for you. I don't know, that's good. This 647.3. And here you could just take the code that my dad provided and start changing some values, but eventually you're gonna have to code on your own. So you can practice, you know, you can practice writing PC. For example, I'm gonna practice here. Oh no, PC. And then when you want to equal it to something, you have to do like this, no, like this. 2 dots. And then that will be equal to, from my table, 22.048 megapascals. And I don't know what I did. Because MPa. Why are you scrolling? All right, and then the eccentric factor from my table. And then you're gonna have to get used to this stuff over here, but I can't go over that now. I'm gonna blame that I don't have a lot of time. I actually never used this before. So here you can get some of the symbols and so on, all right, for when you have to actually code on your own. And here the eccentric factor is 0.344 from our tables. That's great. And then R is the gas constant, so that's gonna stay the same. And now everything changed. Oh my goodness, everything changed in here. What's going on over here? What's going on? Okay, so here it already calculated alpha for me. And I was like, why is alpha calculated here? And then alpha calculated again. This is A, just looks like alpha calculated B. But now I no longer have two values like this. And notice that it doesn't matter what I give it as the guess. This just scrolls really weird. So I'm going, it will end up getting the same value of V. And it's because I just have one face. So I'm going to delete this somehow by goodbye. This is molar volume, just like that. And I'm going to give it any guess at all. 1010. It happened the same thing. So when you're doing these, because eventually you're going to have to do them, all right? You go here to solve block, and then you have your guess values, your constraints, and then your solver, okay? Now this equal sign over here is not the same as this equal sign or this equal sign. So there are some things that you're gonna have to figure out on your own, but you can do it and you're really smart. So you should do that. You should start practicing that, okay? And you can definitely ask my dad if you have any questions. He loves Mathcad. Why does this move? Why did it move to the other side? Me, you're playing here with my feelings. What's going on? Yeah, it's not important, but I don't like that. All of a sudden, there's no equation, right? So I have molar volume. I give it any guess. I have this equation. We already saw it on the notes. It's R times T, and I have T in absolute value, and I have B like this. But we know that the units of that are going to be, it's going to be per mole. So it's going to be molar. So I'm not going to call this B anymore. I'm going to call this. I don't know, you can call it something else because that would be your molar volume that you calculated. And it's going to be that value. Just to hit, that's the actual value, right, that you want for your solution. And then there's no experimental value in this case. So I'm going to delete this and this by, and then, well, my darling, just go away. Wait. All right. So here I have an experimental value. I have a value from the table. And for this, you're going to use your table appendix A, 111. And it's A3. I don't know what I wrote over there. So when you go to appendix A, stop sharing so you can see me. Hello. You go to appendix A, you're going to have the tables. This is actually something, A3, not 111. Something that I'm familiar with. You're going to have your steam tables, all right, where you have mixture of saturated liquid and saturated vapor. Yes. And then you're going to have your tables for superheated vapor. Okay, so hopefully you are comfortable using them. And if you go to your pressure given of 10 megapascals and 400 degrees Celsius, you're still using 673.15 Kelvin for your calculations, but you have your 400 degrees Celsius to come here to the table. You can find that your volume, and this will be specific volume, right? That specific volume is going to be equal to 0.02641. Like, what? So I'm going to go over here. And the table value, this, I'm going to call this specific volume. Please, I'm sure you can call that something better, all right? The specific volume from my table is 0.026, something else. Come on, hurry up. 41. Make sure you know how to find that, all right? And this is very different. This is actually cubic meters per kilogram. You're like, what? So, you know, when you're going to calculate your error and so on, you know, this is not good. So you're going to say this is your table value, but this is specific. So your table value with the correct units, okay? You're going to have to make certain conversions. You're going to have to change that to cubic centimeters, and you're going to have to use that for water. I don't know if it's 18 point something or just 18, but you're going to have to find how many grams per mole or kilograms per mole you have to change that to the correct units. Okay, so this is, you can finish that, but I'm going to tell you now that once you change it, you get, should I say it? Let me show this over here. You get around 475. All right, so I'm telling you the solution now, right? Around 475, maybe a little bit greater than that, cubic centimeters per mole, but you have to show me that you're doing that conversion. Otherwise, I'm not gonna just give you points because I'm the one who raised, okay? Now, one comment, and I'll finish with this. For the second part of the problem, you have to calculate, let's see, you have to calculate enthalpy departure and entropy departure. For water or superheated steam at those properties compared to ideal gas at, I don't remember the value. So for that, that's not this, and that's not this, and not that. But there's another program, okay? And let me see. Mathcad. There's this one, it's posted somewhere online, where instead of finding V, like the root like that, okay? My dad provided this one as well, and he told me that the derivation is somewhere in the textbook. When you can find V using this equation, which this will also give you the compressibility factor, which is good because it will be between 0 and 1. If it's close to 1, it behaves as an ideal gas. And then this code also, you're welcome to use this one, all right? Substituting the values that correspond to your substance, your critical value, and P and T and so on, and the central factor. And then here, it will also help you to calculate, I don't know what says that T. I don't know what that means. I'll check that later. And it will help you calculate the enthalpy departure and entropy departure compared to ideal gas at certain values. Okay, so this is another one that you can use for V, and this one has the same equation. Peng Robinson over here, but manipulate it, all right, over here with these values of Z and A to get that value of volume, and you will get the same because I tried it using both, okay? All right, so hopefully this is helpful, and take care of yourselves, and let me know if you have any questions, and ask my dad about Mathcad. He loves it, and take care of yourselves, right? Bye.